Okay, let's continue with the introduction of amino acid. Now in this video, you are going to learn about what is zwitterion and what is isoelectric point. And at the same time, after that, you're going to predict the structure of given amino acid in acidic medium, in basic medium, and at PI or at isoelectric point. Okay, so let's take a look. I bet this is the first time you learn or you heard about zwitterion, because I know in secondary school never learn about amino acid. And basically, what is zwitterion? It is a molecule. Okay, it must be a molecule that has positively charged group, positively charged group at one part, and also negative charge at the other side. Okay, what is meant by this? Like, okay. Now, usually you will see that one compound, either they can be positive or they can be negative. But in this structure of zwitterion, both charge exist at the same time. Okay, so why these things happen? Because amino acid can undergo an internal acid-base reaction. So basically, carboxylic acid will transfer his H plus, and amine or the at the amino part they will receive the H plus. So I would like to show you the example before I explain much. Okay, so this is our what we call this is our amino acid. So when internal reactions happen, or what we call as internal transfer of hydrogen, what will happen is that this bond, okay, this bond, okay, they will break, and both of the electron will be given to O. Okay, both of the electron will be given to O, which makes this to become negative, and this is become H plus. Okay, so since we have H plus here, it will transfer to this side, and the lone pair, okay, the lone pair here will form it will form bond. Okay, so when it form bond, of course there will be no charge. And what happened? Okay, what happened? Let's see. Our N here will have one, 2, 3, 4. We know N has 5 valence electron, right? It has 5 valence electron, but now only 4 electrons surround to it, less 1 electron, which make this nitrogen become positive. So let's take a look back. As you can see here, this is the 2 charge that we are talking about, and this is what we call zwitterion. Okay, so it's an internal. Internal means it happens inside them. H plus COH tu pindah pergi amino sebelah. Internal, among them only, not from other compound. So this is zwitterion. Okay, so let's proceed back. Okay, so this is zwitterion, as I told you. And okay, fun fact, this zwitterion exists at solid state. Okay, at solid state, at neutral solution. Okay, so let's see. This is zwitterion. Now, amino acid can exist as either it can exist as zwitterion, or can be anion, can be cation. Why? Because zwitterion is an amphoteric. You know, right, what is amphoteric? It can be base, or sometimes it can be acidic. Okay, so what will happen now in acidic solution? Okay, in acidic solution, when zwitterion act as a base, okay, when zwitterion act as a base, so it will react with acid to produce this. So H. So who will accept the H plus? We know we have this one, we have H plus and H2O. So CHR, C double bond O. Okay, we know that this one has negative charge, and now H plus is produced. Okay, H plus is produced. So H plus will be attracted with the O minus to produce what we call as, okay, hold on, yeah. This is O. Okay, so the H just now will become this, positive. Okay, this is when the zwitterion act as base. Okay, but in case OH is added to the zwitterion, OH is added to the zwitterion, what will happen? Of course, it will react with the positive side. By how? By, okay, let's see. Now, since we have OH minus, okay, since we have OH minus, so what will happen? This bond will break. Okay, this bond will break. So, when it breaks, it become lone pair. Oh, sorry. It become lone pair, and the H become H plus. So these two will react together to produce what? To produce H2O. Okay. All right. But the O is still negative here. Okay. So again, when zwitterion accept OH minus O act as an acid, this will happen. Okay, as an acid, so this part will react with OH. Just now, when we have acid, the carboxylate part will react with acid. Okay, so remember, what do you have to remember? Ding, ding, ding. Zwitterion can act as acid, also can act as base, because it is an amphoteric. Okay, do not forget that. Okay, ding, 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 ding. All right, just remember that. Now, Jane, we have another one. This is also new things for you. What is isoelectronic point? Okay, so let's read properly and slowly. So isoelectronic point is the pH. So when we say isoelectronic point, we are actually talking about pH. But what pH is that? Okay, pH that we are talking about is where the average charge of amino acids is 0, and senang cerita, when the amino acid exists as zwitterion. So when the amino acid exists as zwitterion, look at the pH. So that pH we call as isoelectronic point. Now, what is the student's mistake? They will always think that isoelectric point is 7.0, which is the neutral one, right? You get used with that, but no, okay, it does not necessarily to be 7.0, because each amino acid has their own isoelectronic point. For example, as you can see here, the pi for alanine is 6.02, for lysine is 9.7, for aspartic acid is 2.8. Okay, so maybe we can see the exercise for you to see to understand more. Okay, now let's see, we have here glycine. Okay, this is usually the example of the question. They give you the common name, and also they give you the IUPAC name. So when they give you the IUPAC name, I know it's easy for you to to create or to draw the structure. So let's draw the structure first. So 2 amino acids, we have ethanoic acid, CH and H2, H, H, C double bond O, OH. Okay, when it react with acid, okay, when it react with acid, so what will happen? So we are going to get H, C, H, C double bond O. Okay, this is a good tips. When it is acid, of course it will not react with acid, right? It will always react with the base. So ini mesti akan react with this. Okay? Therefore, we have N, H, H. Okay, and then this one. So the lone pair here, okay, the lone pair here will accept the H plus. So it will produce, okay, it will produce H, but we have plus here, plus H2O. Madam, kenapa H2O? Remember, this is H2O and this is H plus. This is the one who will connected with the H here, this one. Okay? So this is the structure of glycine at acidic solution. How about in basic solution? Okay, let's see the basic first. Okay. Alright, let's see the basic first. So for base, it will react in basic solution. We are going to react it with OH minus. Now, like I told you just now, if it's base, of course it will react with carboxylic acid side. Okay, so what will happen? So this structure at amine will stay the same, like this. It will stay the same. But for this one, O, it will become O minus because, okay, because if I can show you, this is H. So basically, this one will be transferred to O to produce O minus, and then the H plus will react with OH minus to produce H2O. So this is the structure. This is the structure for amino acid in basic solution. Okay, this is the structure. Isoelectric point is where both charge exist at the same time. So how are we going to draw this? This one will be C, H, H, N, H, H, H positive, C double bond O, O minus. Okay, I think I make it too big, so let's resize it. Okay, okay, this. Okay, all right, there you go. This is it. So you can try okay, never mind. We just continue with the next questions. Now, the PI value, okay, the PI value of serine. Okay, the PI value of serine to amino 3-hydroxypropanoic acid is 5.7. Draw the predominant structural formula of serine. So in solid phase. So let's draw the amino acid, okay, without the charge. So we have 2-amino-3-hydroxypropanoic acid. We have propanoic acid, C double bond O, OH. Okay, so this will be the parent chain. Okay, this will be the parent chain. And then this one will be carbon number 1, 2, and 3, right? So 3-hydroxy. So 3-hydroxy will be here. And 2-amino will be here, and then complete it with the other H. Okay, this is your parent chain. Okay, so this is 2-amino 3-hydroxypropanoic acid. Okay, now given to you the pi is 5.7. Okay, so we know when we say pi means the amino acid is at ZWITTERION. Okay, it's at ZWITTERION. Therefore means this one would be basic and this one will be acidic. So we need to draw the structure of serine in acidic, in basic, and in ZWITTERION. So let's do it by one. So in acidic, okay, in acidic, okay, if you're good enough, you know already. If it's acidic, so therefore this part will be disturbed, right? Okay, this part will react, not disturb, react. So we are going to write as HCOH, HCH. This one, if you can also make it like this, NH3+, because we know H+ will go to that side. So this one will maintain the same. Okay, so this one in acidic. In basic, okay, so in basic, this part, the carboxyl part, will react with the OH. So we are going to get HCOH, H. C double bond O, O minus. Okay, because what will happen, this H+ will go out and be taken with, will react with OH minus. Okay, so that is basic. You can label this pH1, this one pH 14. So at pH 5.7, which is ZWITTERION, the structure will be like this. There you go. As you can see, we have two charge over here. See, now we have two charge over here. So this one is pH 5.7. So that's how you answer the question at page 10. Okay, so that's it for the introduction in your second part. In the next video, you're going to learn about the chemical reaction of amino acid. See you then. Bye.